Hello, everybody. So what we're going to be looking at today is section 3.2. Says that on the screen, but small, so I'll rewrite it. Section 3.2. Now, I think what we're going to do is break this apart into two lectures. And so hopefully we'll get through half of these notes in this first video and then half in the next video. So let's say that this is part one. Um, I guess I could change my mind before we get to the end. We'll see. So anyway, with that being said, let's go ahead and get started. So yeah, so where we're going to start is with the learning objectives here. So in this section of the book, which is section 3.2 in the OpenStax College Algebra textbook, um, we're going to be looking at the domain and range of a function. Now, specifically, what we're going to be doing is we're going to learn how to find the domain and range of a function from a graph or from an equation. Also, I'll remind you of how to do this from a table, but we learned that in the previous section, section 3.1. After we do that, then we're going to learn about piecewise defined functions. So piecewise defined functions is what might end up in the next lecture. We'll just have to see. Okay, so let us continue on. So you need a definition of domain and range if you're going to be, well, of course, finding these things. So here's a definition that you could use. This isn't the very thorough formal definition. You can get that from your textbook, but this is what you need to know. So the domain of a function y equals f of x. So the name of the function is f of x. The input is x and the output is y. That's the notation that we typically use. So x is input and the y is output, right? So you plug an x into a function and then out comes a value, and the value we call the output. So with that notation, the domain of the function is the set of all x values for which f of x is defined. So you can't always plug in every x value that you want. So whatever you can plug in, that's the domain. Okay. Now the range of the function is going to be the set of all y values where the function's defined. So you put in whatever x values are allowed and out come some y values. Whatever the y values that can come out of this function are, that is the range. Okay. The key here really is just the x values for the function are the domain and the y values for the function are the range. So if you're given a problem like this first example, which is not labeled as an example, if f of x is defined by these ordered pairs, and we want to find the domain and the range of f of x, you just have to keep in mind what you're doing here. Which one's the input, which one's the output, or which one's the x, which one's the y, right? And of course, in each pair, they're an x and a y. So your domain of this function is going to be the x values. And the way we write this is you put it in curly braces. Curly braces indicate a set. And then we're just going to list all of the x values. So your x values here are 1, 3, and 5. So 1, 3, 5. That's the domain. Now your y values are going to be the range. So our y values are 2, 2, and 3. So notice that we've got 2 listed twice here. Well, a set doesn't need to list the same thing twice. It's just a list of all of the things. So when you list the range here, you don't say 2, 2, 3 like this, because that set is actually the same thing as just 2, 3. You don't need to repeat anything. That's the point. So even though it's 2, 2, 3, you just list that as 2 comma 3. The order here does not matter. So you could put the 3 first and the 2 second. That would have been okay. Same thing here. The order doesn't matter. You could put the 3 before the 1. You could put the 5 first. None of that matters, right? This is just a set with 1, 3, 5. This is a set with 2 and 3. Okay. So if you've got like tables like this, that's all you have to do. And so sometimes they list it this way with ordered pairs. Sometimes they will put the numbers in a table like this. And this one right here is exactly as easy as the previous one. We're just listing X values and we're listing Y values. That's it. So let us do this one. Let f of x be defined by the ordered pairs in the table, x's, y's. So we know how to do the domain and range now. The domain is all of the x's. 3.1, 3.2, 3.3, 3.4, 3.5. That's all of them. Now your range is all of the y values. You need to list all of the ones that are there, but you don't need to list them twice. So they are 1, 1.52, 1, 1.5, 2, 1.51. Well, we already have 1.5 and we already have 1. So again, we don't need to list those twice. So that's it. That's your range. So when you've got a table where just a certain number of x values are allowed and just a certain number of y values are allowed, all you do is you just list them like this in your curly braces. And in the homework, I think they say to use curly braces when they want you to do that. Okay, now let's extend this to looking at graphs. Now, when you're finding the domain and the range on a graph, it's still x's and y values, but what you're going to get is intervals. If you look at this first graph here and you want to try to find all of the x values, you need to think of it this way. Let me get a highlighter here. So right here, the function starts and it goes up and then it comes down and it ends up down here. But if you look at this, all of the x values starting at this x value, -1, up to this x value, 2, are used, right? So all of the x values between here, this section of the graph, is the x values that are used. So if I was going to like kind of highlight these, everything from here up to here, that's what gets used for the x values, right? From -1 up to +2. That's your domain. Get a color. That's not what I wanted. Let me get a color. That is your domain. Now, that's not how you write it. I'm just highlighting it there. So the domain is everything starting at 1 and going up to 2, because those are the x values that you see on your graph. So your domain here, domain, is an interval that starts at -1 and goes up to 2. And it's going to be square brackets on the left and parentheses on the right. And the reason for that is going to be this empty circle here. This empty circle indicates that the value of 2 is not actually part of the function. So empty circle means not part of the function. So empty circle here means that this point, which is 2, 0, is not actually part of the graph. That's why it's empty. So since 2, 0 is not part of the graph, then we want to leave out the 2 right here. And the way you leave off a number from an interval, of course you'll remember. Oh, sorry. The way you'll remember this is that parentheses indicate that the point is not included, and square brackets indicate that the point is included. So you've got to be careful to use 2 with the parentheses here. Parentheses. to indicate that x equals 2 is not included. And here we've got square bracket. And so the square bracket indicates that in this case, the minus 1 is included in the domain. Because on the other end, it was a solid dot, right? So solid dot means that the point is there. So this point is, so solid dot, because that point, which is negative 1 comma 3, negative 1 comma 3 is part of the graph. So hopefully that makes sense. So that's your domain. All of the values from negative 1 up to 2, but we don't include the 2 because of that empty circle. Now I'm going to have to move this around a little bit. Let me take this and I'll move it here. Erase that arrow and new arrow. Okay, so the reason I'm doing that is because we want to move on now and we want to look at the range. So the range of this function, remember, is the y values. So we need to look at what y values are used here. Now, in this section of the graph, which is the entire graph, all of the y values starting up at 4 all the way down to 0 get used. So it's not necessarily the point at the end that you have to look at, right? Because if you only look at the points at the end, you might think that your range is only from 3 down to 0. But that's not it, because clearly the graph is above 3, right? This section of the graph is clearly above 3. So that's not the way you do it. You got to all of the y values that you see on your graph. So the y values start down here and go all the way up to 4, right? So that's your range. All of the y values you see on your graph. And then we need to write it in the interval notation exactly the way we did the previous one. So it looks like down here, of course, this is y equals 0. And up here, this is y equals 4. So our range is going to be from 0 all the way up to 4 for the y values. So we say it's 0 and 4. And then we need to decide on not empty circles, on square brackets or parentheses. So the bottom of this graph down here at y equals 0, there is an empty circle there. So that empty circle means that we should have parentheses on that end. At the top end, up here at 4, well, there is no dot, right? There is no dot. But you can look at this graph and assume that this does actually get up to y equals 4. Because if they did not want there to be 4, if they didn't want 4 included, they would have put an open circle there to indicate that the point was missing. They didn't indicate that this point was missing right here, so you just assume that it is included. And if it is included, that would mean a square bracket like that. Okay, so that's your domain and that's your range. Now, just to be clear, there are other ways to write this. So we could have written the domain maybe this way. Let me find a place to write it. An alternate way to write this domain would have been negative 1 to 2 is correct, but you could have also said that it is x between negative 1 and 2, like that. And then parentheses would mean that we use less than, and a square bracket would indicate that we have to use less than or equal. So you could have also listed it this way. So this would have been how to say it as this would be a compound inequality. but it's the same thing. And you could do the same thing for the range as well, although it's a little bit trickier to think about how to write that. I'll show you why. The range is from 0 to 4, as we see, but you could have also said that the y values are between 0 and 4, and then there's a square bracket on the 4, which means change that to equals. Or if the function had a name like f of x, you could say that f of x is between 0 and 4. Right? The problem with a compound inequality is that you have to have the variable in the middle, so you need to know what to write there. So y, or the name of the function, something like that would do it. Now, I'll say this, probably the majority of the questions that you have on the homework, they want this form. But there is one or two where they specifically ask for the compound inequality. So you just need to know how to write it both ways. Okay, let's move on to this graph. Conceptually, there's no difference here. From a practical standpoint, there might be. So again, domain and range, we're thinking about x values and y values. So for the x values, all of the x values going out forever in this way, all the way up to 0 get used, right? That's this section of the graph. Now notice I left a little gap there. I left a little gap there because right at x equals 0, you don't actually see anything. That's missing. And then you've got another section of the graph, just on the other side of 0 that goes this way forever. And so that's your domain. Again, I messed that up. So that's your domain. It's everything except 0. All numbers except 0. I'll say x equals 0, which is easy enough to write. You have to know how to do this though. If we want to leave out x equals 0, the way you have to do it is you have to list it in two pieces. The piece over here, you assume the graph just continues out forever this way, goes out to negative infinity. Like way out this way is negative infinity, and way out this way is positive infinity. So you have to write this domain as everything from negative infinity up to 0. That's this part. And then this part over here would be everything from 0 up to positive infinity. And if we use parentheses like we did here and here, that indicates that 0 is not in this, 0 is not in this. So 0 is not in either, which is why we're leaving out x equals 0. Then you put a union symbol like that to indicate that we are sticking these two sets together. So that's your domain, two pieces, one over here, no 0, no 0. If you wanted to list this as a compound inequality, it'd be tricky. Yeah, it'd be tricky. You'd have to say something like x is between negative infinity. Actually, you'd have to say it like this way. Like this piece would be x less than 0, or this piece, which would be greater than 0, like that, something like that. Again, this is your answer most of the time. Now, for your range, same thing, range. What are we going to do? Well, your range is the y values, which is very similar to how we just did the x values. The range goes from down here all the way up to 0, except it doesn't actually hit 0. It jumps over 0 and then starts and then keeps going again. Right? Like this goes out this way and then goes up forever. This goes down forever. And right here at 0, there is no actual curve. So it's exactly the same idea, where way up here we have plus infinity, way down here we have minus infinity. and this one goes minus infinity up to 0, and then jumps over 0, 0 up to infinity. So it's really, the range is going to be the same as the domain there, but it's y values and not x values. So this is your range. And up here, this is also your range. Now, you don't draw like this on the graphs usually to get your domain and range. That's just me trying to help you understand what's going on. Um, you just write it and look at the graphs. And that's it for graphs. If we wanted to look at the homework real quick, I think it'll go pretty straightforward here. There's an assignment. Let's do teacher preview. I'll do a couple of these problems real quick. All right, so this is the homework. So the set of all possible inputs to the function. Well, inputs are domain. See, easy. Um, I'm not going to list these. If you are trying to do a problem like this, where they give you ordered pairs, and you need to list the domain, just pay attention to what the problem says. Ordered list, it says least to greatest enclosed in curly brackets. Just pay attention to the instructions. So you have to domain, we need curly brackets. Not so easy to get on an iPad. I think, oh, there it is. Shift, curly. And then you just make sure that you list these in order. So like negative 19, negative 7, 4. Do we need commas? Probably. Um, negative 4, 19, 38, 50, right? And then you got to close the braces. This is not a decimal or integer value. I'll submit that. Only got half of it or a third of it. Okay, I'm gonna try this again. I'm gonna try this one. Um, Ordered list, least to greatest, um, curly brackets. So all of the y values, we need to list them least to greatest. So I think the smallest y value is 25 from the 50, 25. The next one is 40, I see. The next one is 62, 65, 98, 99. So I think I've got that. That one's right. I don't know why I didn't get full credit for this one. Is it spaces? Why would I? I don't understand what happened. Don't understand. Oh, I missed a comma. I missed a comma. Okay, that's all. All right, so that's easy. I wanted to mention just graphs. Hold on a second. You go away. You go away too. Fine. Web browsers complicated. Do we have any graphs? Oh, well, we have the same problems that we just did. Yeah, I guess the only ones there's the ones that we just did as samples, and then there's this one, right? That's it. So like the domain here would be, it looks like the smallest x value I can't really write, but is this one that you see in the middle of the screen. Oh, I can kind of move it around. Um, so that x value is -3, and then all the way up to, come on, x equals 4, right? So hopefully you can see that. So in interval notation, this is um, from -3 up to +4, like that. And in um, compound inequality, that would be -3 less than or equal to x less than or equal to 4, like that. Submit. And I know I only did half of it, but submit. And you see those are both right. Now, the problem is that you might have to look at the video to see how to write this. Oh, that's the key. So let's see how they want this written as a compound inequality. So they do want it with y. So how we were talking about on the notes um, here, this is how you'll write it on that type of problem. Okay, I did the domain. I didn't do the range there, but that should be fine. Okay, so now let's move on and we talk about domain and range when you're given an equation. So the key to doing these problems right is well, I was going to say to understand what you're doing. Of course, that's always the key to doing the problems right, right? Is understand everything. Um, but here's the key. So when a problem asks you to find the domain of a function, you want to think about what x values are not allowed. Um, what x values are not allowed. Okay, so by default, what you do is, oops, by default, what you want to do is um, start with like the domain being like -infinity to infinity. That's everything, right? And then you're taking stuff away if you need to. So then you take stuff that's not allowed away. Now, what would not be allowed? Well, there's a couple of things that you're going to see. The things that are not allowed for us are you can't divide by 0. That's not allowed. And you can't take the square root of a negative. When you take the square root of a negative number, you get an imaginary number. And for now, in this section, imaginary numbers are not going to be part of our intervals or anything like that. So we can't list numbers that way. So you can't take the square root of a negative is a rule for now, right? You can, but you get imaginary numbers. So this is a rule. Now, yeah, so that's it. Now, regarding what I said here, where you start with the idea that your domain should be infinity to infinity, and then you take stuff away, the way you would apply that is if you go down to like page 4 here, which I will, here's some questions that don't have fractions and they don't have square roots, right? So, like if you look at this function right here, so there's no possible divide by zeros, right? Because there's no x's in the denominator. So there's no divide by zeros, no divide by 0, and there's no square roots, right? All x values are allowed. All possible x values are allowed in this function. So when you're writing the domain here, there was nothing not allowed. And so by default, you just say, well, that domain there is going to be -infinity to infinity. Okay. And the same thing on this one. This one has a cube root, but we were talking about square roots a minute ago. We said you can't take the square root of a negative number. You can take the cube root of a negative number. So this also has no divide by zeros or square roots or anything bad. So there's nothing to limit the domain here either. So this domain is also -infinity to infinity. So when all you have is polynomials like this, or if you have a cube root, then there are no issues to deal with. And so you just list negative infinity to infinity to indicate that every x value is allowed there. Okay. And just to hopefully show you what I mean, if we go back here, let's look at Wolfram Alpha. So if I type in a square root, which I can't type in the symbol, but I'll use this as square root on Wolfram Alpha. If I type in square root -8 like this, hopefully it'll tell me some kind of problem. Well, it's imaginary. So it's imaginary, so there's no real answer there. Um, if I change this to a cube root, which you could type in this way, cube root -8, that's just -2. And that's very simply, it's -2. The cube root of -8 is -2 because if you were to multiply this out, -2, -2, -2, of course, you get -2 times -2 times -2 is -8. And that's why the cube root of -8 is -2. The point I was trying to make there is that it's not imaginary, right? Cube roots are fine. Cube roots are fine, they're not imaginary, even if you take the cube root of a negative. Okay, so let's back up to problem 2 and what happens if there are issues with your function. So I've kind of divided this up into two cases, right? Divide by zeros and square roots. So these problems will look like this, right? Like find the domain of f of x equals 3 over x plus 2. You see the x in the denominator, and you know this rule. You can't divide by 0. So if you can't divide by 0 and you see a denominator, you need to make sure that denominator is not 0. So what you do is very simply, you set the denominator equal 0. That's what's not allowed, okay? So you take this denominator here, x plus 2, you set it equal to 0. That's not right. X plus 2 equals 0. And of course, then you solve it. So this is a very simple equation. So minus 2 from both sides. You get x equals -2. Okay. Now that x value is not the domain. That x value is where if you plug x equals -2 in here, there's a divide by 0. So that's what's not allowed. So x minus 2 is not allowed. That's what's not allowed. Okay. So then your domain is all x values except that one. Everything except x equals -2. Now, how are you going to write that? Well, we already have seen an example of how to write that up here. Right? This right here is how you write all of the x values except 0. So all you do is you copy this notation, but you put a -2 where that 0 is. And that's how you say everything except -2. So we say the domain is from -infinity up to -2, union -2 up to infinity. And you got to make sure to use parentheses because we do not want to include the -2. So like on a number line, which is not the answer, but like the idea is this. If -2 is here, we want everything this way and everything this way. But right here, we want to leave out. So this right here is this, and this one over here is this. So your answer is actually, oops. So your answer is actually this. Okay? All of the x values except -2. Okay, So that's the procedure that you follow on all of these. So like find the domain of 1 over 5 minus 3x. So this can't be 0. So we know that we should denominator can't be 0. That's what can't happen. Okay, so we set the denominator equals 0. So 5 minus 3x equals 0. Solve this however you want. So I'll do minus 5 minus 5. Negative 3x equals negative 5. Divide by 3. Over negative 3 over negative 3. We get x equals just 5/3. Positive 5/3 because a negative over a negative is positive. So we get this number. Now remember, that number is not the domain. That number is what is not allowed. So the domain is everything except that. All numbers except x equals 5/3. Now, how do you write that? Well, we've already seen how to write it. Negative infinity up to 5/3 union 5/3 up to infinity. Right? Same thing. Same thing we had in the previous problem, just a different number. Okay? And that's how these go. So let's do the last one. Last one's going to be the trickiest one. Find the domain here. Now, they can trick you, not trick you, but they can put whatever they want in the denominator, right? And it's up to you to figure out what x values are going to make this not, or what x values are going to make this 0. You got to figure it out. Now, you can do it by hand, but you could also not do it by hand. You can do it with a computer. So we know to do this, we should, again, set the denominator equal to 0. So x squared plus 5x plus 6 equals 0. We need to solve. Now, I'll solve it by hand, but you don't have to. You can go over to Wolfram Alpha, right? wolframalpha.com. Hopefully you can see that on the screen. And we can just say x squared plus 5x plus 6 equals 0. That's the equation. And we get solutions. X equals negative 3, x equals negative 2. X equals negative 3, x equals negative 2. And so you can just do that right here. X equals negative 3, x equals negative 2, and then move on. Okay? That's perfectly okay to do on your homework. If you want to do it by hand, you can. You would have to solve this equation with the quadratic formula or factor. If I factor, I'm looking for numbers that multiply to 6 and add up to 5. I can think of those numbers right away. They're 2 and 3. So this is x plus 2, x plus 3 equals 0. And I know that that means x plus 2 equals 0 or x plus 3 equals 0. And this one gives you x equals minus 2. And this one gives you x equals minus 3. So you're going to get those if you do this by hand, or you're going to get those if you do it on a computer. Now, that means that your domain is everything except those numbers. So domain is all numbers except x equals negative 2, x equals negative 3. And so on a number line, what that is this. So I'm doing it on a number line, hopefully to make this a little more clear what's going on. So you have a number line, negative 3 and negative 2 are on there like this. And this is actually 3 different sections now, right? Because what you've got is you've got a section over here, you have a section in the middle, and then you have a section over here. Because what we want to do is we want to leave out the -3 and leave out the -2. So we're going to write it in this type of notation, but instead of just having one number to leave out, like 5/3, we have to leave out the -3 and the -2. So you have to write it in three pieces. So your domain is actually, this section of the graph is -infinity up to -3. Let me write it in a different color actually. So give me a second here. Okay. So the section on the left, this is -infinity up to -3. This middle section is -3 up to -2. And then the section all the way on the right is -2 up to infinity. So when you go to write your domain, you need all three of those. -infinity up to -3, parentheses to leave out the 3. -3 up to -2, parentheses on both sides to leave out both of them. And then -2 up to infinity, to leave out the -2. So do you see, like, -3 is not included in either of these, and -2 is not included in either of these, and we have all three sections, but with the two values that we need to leave out left out. Okay, and so that's how you do that. So that's, obviously a little bit trickier, but the logic, like, there was no extra thinking to do, really. I mean, we had to learn how to write this, but this part was where all the work is, really. Okay, so just to see if we can do these, let's go back to the homework. See what you got in the homework that looks like this. I'm not going to do all of them right now. Sorry, I just need to scroll. Let me scroll, please. Okay, we can scroll. Yeah, so there's different types here. So like this one right here, like, what's the domain? Well, we got this x squared plus 13x plus 40, right? That can't be 0. So you can factor that by hand, or you go to Wolfram Alpha, x squared plus 13x plus 40. X squared plus, we forgot 13x plus 40. Is that what it was? Yeah, x squared plus 13x plus 40 equals 0. You can solve that. We've got two numbers, -8 and -5. Those are the roots, which are the answers there. So, oops, -8, -5. So you come back here and say everything except that. So that is negative infinity up to -8, close the parentheses. We need the union symbol, so I have to click on interval, union symbol. -8 to -5, -8, -5. Come on. What? I need you to be on the other side of the equal sign here. Okay, finally. Union. What do we need? We need -5 up to infinity. Infinity was on basic. Okay, right? So do you see how fast I solved that? Because I just had a computer solve it. I could have tried to factor this. 5 times 8 equals 40. 5 plus 3 equals 13. So you can factor that denominator yourself, but submit. Right? So there you go. It's not that hard. This one right here is identical, just a different answer. So you can just do that. If you get one like, sorry, some of them you can just eyeball, like this one right here, where you see it's so simple, the x plus 20. You can just look at that and say, -20 not allowed. And then you can just write your intervals negative, negative infinity, negative 20, close union symbol, negative 20, positive infinity, right? You can just eyeball that. You don't need to do any math um, and get it right away. So those aren't so bad, right? The fractions, this one you'll have to solve by hand. It's not that hard. And that's it for the fractions. We still need to look at those square roots. So let's look at these square roots. So square roots are a little bit different. Remember that you can't square root a negative, only 0 or greater than 0. So what you do is what I said here. So when you have a function like this, square root x plus 5, the function is defined for all x values where the expression inside the square root is greater than or equal to 0. The expression inside the square root is greater than or equal to 0. So what you do is you take whatever is inside the square root and you put greater than or equal to 0 and solve it. So these are actually these are almost always easier than the fractions. So you just take the inside, take the inside of the square root and set it greater than or equal to 0. That's what you do. So it just looks like this: x plus 5 greater than or equal to 0. And then you solve it. Now, solving it is often very simple. Like on this one right here, you just do minus 5, and you end up with x greater than or equal to minus 5. Okay? Now, what's different than the other problems is that the way I did this is I set it greater than or equal to 0. That is allowed, right? In the previous problems, we were looking for x values that were not allowed. On this one, greater than or equal to 0 is allowed. So this is actually the domain. Okay, so like if this is the first part, then the second part is your domain is x greater than or equal to negative 5. Okay, that's what is allowed. So then you have to write that as an interval, which is not that hard. Greater than negative 5 is negative 5 up to infinity. So they're even shorter to write than the previous problems, okay? But that's it. That's the domain. And you can see that that's correct because, for example, if you try to plug in something in this interval, like let's say you try to plug in f of negative 3, is that allowed? You might be confused because you think, oh, didn't we say you can't square root a negative? But just try it. Try negative 3. If you try to do f of negative 3 in this function, it's square root negative 3 plus 5. So it's actually the square root of 2. And that's fine, right? Because that's positive. So yeah, you can have a negative number here. You can have a negative number here. It's just when you work out the square root, that's got to be positive in there. And that's what setting this greater than or equal to 0 does, is it guarantees that this number will be positive by the time you get to this point. Okay, so there's your domain. And really, you just do the other problems this way as well. So like on this one, inside square root needs to be greater than or equal to 0. Now, the key here, the reason I put this one on the list is because you have to pay attention to what's in the square root and what's not. This is all inside the square root. The 7 is outside, right? I don't care about this 7. This 7 is not affecting the domain at all. the domain has to do with whether or not we can plug in a certain x value. The square root is the only issue. So the square root is the only part I need to look at here. I need that inside to be greater than or equal to 0, right? So we're only looking inside the square root, not outside the square root. So 4 minus 8x should be greater than or equal to 0. And then you solve this. You have to solve this by hand. It's not going to be that hard. I mean, you could type it into Wolfram. So to solve this by hand, I'll probably do minus 4, negative 8x, that's going to cancel, greater than or equal to negative 4. You have to divide by negative 4. So divide negative 8, negative 8. You're going to get x, you're going to get, I have an eraser for some reason. So those cancel, give you x. When you divide by a negative, the symbol flips. So make sure you understand that. And then negative 4 over negative 8 is 1/2. Right? So this is your domain, but it's not written the right way. So domain is this. Domain is x less than or equal to 1/2. And that is less than 1/2. So that means it is domain like this. Right? Because we want less than negative, or sorry, we want less than 1/2, not greater than 1/2. So greater than negative 5 is to the right of 5, and less than 1/2 is to the left. So down to negative infinity. All right. One more problem and we'll be done. So here, find the domain of h of x equals. So this one is the trickiest one because there's actually two problems here. Because we've got a square root and we've got a denominator, right? So we got to make sure we take care of both of those issues. So there's two issues here. Two issues. There's a square root and a fraction. So we have to deal with both. Okay, so which one do we want to deal with first? I think the easiest one to deal with is going to be the square root part. Okay, so let's deal with the square root part first. Square root part. So we know inside of the square root should be positive. So we just did those, right? So the part that I underlined needs to be greater than or equal to 0. So x minus 2 should be greater than or equal to 0. And just add that 2 over to the other side, plus 2 plus 2. We get x has to be greater than or equal to 2. Okay, so that is part of the domain. Or part of the information we need for the domain, I should say. That's not actually necessarily part of the domain. Okay, now the other issue we have to deal with is the divide by 0. Right? There could be a divide by 0. Divide by 0 part. So for divide by 0, we know what's not allowed is the denominator to be 0. So denominator, we should set equal to 0 to find what's not allowed. So set denominator equals 0. So you just have to write it out. This looks complicated, but this is what we get. Okay. So we set the denominator equal to 0. We have to solve it. It's not as hard as you think. If I add square root x minus 2 to both sides of this equation, right, it'll cancel. I'll get 4 equals square root x minus 2. Then I can square both sides. So I want to square both sides. So square, square. This side is 16. 4 squared is 16. On the other side, the square cancels out the square root and gives you x minus 2. And then you could add 2 to both sides. And you get x equals 18. Okay? So this x value is not allowed. Remember, when we set the denominator equal to 0, that's because that is not allowed. So x equals 18 is not allowed. All right? So then you combine your information. Your information says that x equals 18 is not allowed, but x greater than or equal to 2 should be part of the domain. So combine that information, the results here, combine the results. The domain is x values greater than greater than 2. X values x greater than 2, but not including 18, right? Because 18 is not allowed because of the divide by 0. So on a number line, looks like this. So the numbers we care about are 2 and 18. So x greater than or equal to 2 is like starting right here and then going this way, right? That's x values greater than 2. But x equals 18 is not allowed. So right here, you need to actually erase a point and put an empty circle there. So I'll have to erase this. Oops, not exactly what I wanted. Okay, so what you actually have to do is erase this point and go, okay, well, it's that side and it's that side, right? So it's like the previous problems where there's over here and over here, two pieces. So your domain is this. It's from 2 up to 18, 2 up to 18, union 18 up to infinity. Now that's hard. Like that was a difficult problem, but that's what happens. You get greater than or equal to 2 from the square root part, but then from the divide by 0 part, you get x cannot be 18. And so that's greater than 2, but not 18. So from 2 up to infinity, but not including 18, you have to remember how to leave 18 out. Okay? So that's it. In the next lecture, what we're going to talk about is piecewise defined functions. It's going to be a shorter lecture than this. I just wanted to finish this topic before we moved on. So that's it for now. I will talk to you guys later.